Hello all, today we are going to be learning about regression, which can include linear, exponential, and quadratic for us. So the question is, what is regression? Well, regression is a statistical method used in finance, investing, and other disciplines that attempts to determine the strength and character of the relationships between dependent variables, which is usually a y when we write it, and a series of other variables. Those are our independent variables, which is usually an x, but those variables can change. It's our inputs and our outputs, things like that. So, like our previous lesson where we use stats blue to help us analyze a data set, we are going to use stats.blue and choose either simple linear regression, exponential regression, or polynomial regression, depending on what the data set is and what it asks us to solve for. We can also use graphing calculators to find a regression model, but stats.blue is a little more easy to find and navigate, so we're going to stick with that. So our first example here, in a math class, we have 10 students, and the teacher wanted to determine how a homework grade influenced a student's performance on the subsequent test. The homework grade and subsequent test grade for each student are given in the table. So you've got your table of homework grades, which is written as X, and you have your table of test grades, which is written as Y. Now, the other day, I sent you an email that had a link to a Google Sheet. If you pull that up, you will see that there are tabs along the bottom. One says analyzing, one says notes regress, and one says homework reg, stands for homework regression. I want you to click on the notes regression, and you'll notice that all of the information that you need for these notes are within that tab. So, once again, we're using stats.blue, so like our previous lesson, you'll go ahead and copy each column, and then you will go to stats.blue, and this time you won't choose one variable descriptive statistics, but this is a linear regression, so you'll choose the blue linear regression, and you'll go ahead and paste this in. Okay, so I also want to type in my variable name. This I'm going to say is homework grade. I'm also going to put an X there too, just to help myself remember that that's what I'm dealing with. And then my Y is test grade. And I'm going to put a Y here too. You'll see why I do that in a minute. Now, I do still need to copy over this test grade info. So let me go ahead and copy this and paste it in here. And then I do want to use the include regression line, and I'll use 4 decimal places, so I'll hit calculate, and it brings up a scatter plot for you with the line of best fit on here. It's also called a regression line too, 2 names for it. It also gives you an equation for that regression line. So you'll see here why I wanted to put the Y in there as well, because it's kind of weird to see test grade and homework grade within an equation. It gets a little crazy. So instead, I'm going to use X and Y like the variables on here say. In part A, given the equation of the linear regression, what is the line? Well, it is Y equals 0.8345 X. I know there's a whole word in there. It's just X, and then plus 14.6496. Now it's easy enough to just get your calculator to find this equation, truly. But what we really want to be able to do is predict outcomes with it. So if a new student comes to the class and earns a homework grade of 78%, based on the equation in part A, what grade would the teacher predict that they would receive on the test? So because homework grade is X, for X I'm going to plug in 78. Okay, so this just means that I can take 0.8345, multiply that by 78, and then if I add 14.6496 to that, I get the student's final score. It does went to the nearest whole number or integer, so we have about 80% that the student will get on the test. Spelling. Okay, so this regression line, if we look at this diagram here, kind of helps us predict where each student will be based on their homework scores. And we can also plug things in to find a more exact approximation than looking at the graph. Okay, so that's pretty much it. It does get a little crazier on some of these, just given different things, but not too bad. So in this next problem, we are asked to find a couple different things. Let's read it first. We have two different tests were designed to measure understanding of a topic. The two tests were given to 10 students with the following results. So they took both tests. They scored either better or worse on each one. We're going to construct a scatter plot for the scores, then write an equation for the line of best fit. We're going to round and slope and intercept to the nearest hundredth, so that's 2 decimal places. And then we'll find the correlation coefficient as well as predict what a score will be and decide what this correlation coefficient means. So lots of things going on in this problem. First thing we need to do, though, is replace our data in stats.blue. You can go ahead and just type everything in if you want. It's all given to you there. You don't have to use the Google Sheet. I just find it easier to be able to pull it up. So let's see. We need to now use the second information. So this is test X and Y. Let's do the other one. And then include the regression line and hit calculate, and it will calculate this new set of data. Now notice it already gives us a scatter plot. So we're going to make sure it looks correct and graph it, okay? So we have our first things first, regression line. It does say just 2 decimal places this time. So we have y equals, notice it says test y and test x. You can just bring it down to x and y. It would be 0.63x plus 28.79. Okay, so just 2 decimal places as it asked, and this is our line of best fit. That is the fit for this red line here. That's how they graphed it. Now, to graph my scatter plot, my x-axis is going to be test x info, y-axis is test y info, and then I'm going to count up by 5s from 0. So it's going to take a minute, and then I'm just going to plot it. So on your own time, you can go ahead and plot all of this. Now don't get lazy, you have to include the labels for each axis as well as how much they count up by. So don't not include that. And then plot all 10 points. Okay, you'll notice once I finish, it's not perfect, but it looks pretty similar to the one to the left here on stats.blue. So we will go ahead and move on to the next thing. It doesn't ask us to write the line in, so it just asks us to plot the points. That's all I'm going to do. Now, the correlation coefficient is actually something called your R value, or as it is on stats.blue, it's literally just called correlation, and then says R equals. So our correlation coefficient here is R equals 0.9129. Now we're going to skip that next section for a little bit and come look at this. So based on the correlation coefficient, is there a strong positive, strong negative, or weak negative, or no correlation here? So if you just look at the graph, it has a positive slope. So it looks like it has a positive correlation. The question is it strong or is it weak? Now how we know is we just look at our R value. If the R value is close to 1, it has a strong positive correlation. If it is close to -1, it has a strong negative correlation. If it's close to 0, that means it has no linear correlation. If it's somewhere between 0 and 1, it has a weak linear correlation. And if it's somewhere between 0 and -1, it has a weak negative linear correlation. Okay? So that R value tells you kind of how well the regression line is centered in the points. So you can actually do this by hand. It's really hard to do. That's why I'm not teaching you how to do it by hand and just having stats.blue do it for us. But we can look at the correlation coefficient and kind of get an idea of how good this line actually is for this data set. Sometimes they're not good at all. It's not really linear. So I would say there is a strong positive correlation here because it's pretty close to an R value of 1 and it's positive. So then we're going to predict the score, so same as last time, to the nearest integer on test Y for a student who scored 87 on test X. So we take our equation, we plug in 87 for X, so I'm going to replace X with 87, and then I will solve. So it does say round to the nearest integer. This person would probably score 84% on test y. Okay, so those are both linears. You'll notice at the top of the Google sheet that I give you, I kind of give you a hint of what they are. So at the top of this one, example 1 and 2 both say linear. You'll see example 3 is exponential. So let's look at that one. We haven't actually learned about exponentials yet in class, but we can use what we do know to do this regression stuff before we even learn anything else. So a box containing 1,000 coins is shaken. The coins are emptied onto a table. Only the coins that land heads up are returned to the box. And then the process is repeated. The accompanying table shows the number of trials and the number of coins returned to the box after each trial. So in science class, you guys might have learned about half-life. That's really what this is. It's an experiment for half-life. We could do it too if you haven't done it in science, but that's what this is really looking into. So it specifically says that it's going to be an exponential regression equation, and then we are going to round to the nearest 10,000ths. That's 4 decimals. Okay? So we don't want to be with linear anymore on stat.blue. We actually want to come down here to the orange exponential regression calculator. And we will plug in this data. This is a small enough data set. It's understandable if you just want to type it instead of copying it. So our explanatory, or our trial, is X, and our coins returned is Y. This is once again going to make our problem look kind of weird, but it's fine. All right, we'll go ahead, we'll run it, make sure you're on exponential. We are. Calculate. Okay. So if you notice on this graph, this is actually a really good exponential regression model. Our R value for this exponential is actually really close to -1 as well. So it's modeled very well by this exponential equation. It's almost perfect, actually. So we're going to go ahead and write that equation out. So our coins returned is Y. So Y is equal to, and if you're not sure what the form should look like, it's up here, the exponential model. Y equals A times B to the X. Oops. That is what this looks like. So Y equals 1,018.2839 times 0.5969, and then this is to the x power. Different than linear, to the power of x. Now, same thing, similar as before, we want to actually try to predict some outcomes. So we're going to use the equation to predict how many coins would be returned to the box after the 8th trial. So x is trial numbers. So we're going to plug in 8 for this. And then in your calculator, you'll just go ahead and solve this. So you take 0.5969 to the 8th power. And then you'll multiply that by your 1,000 number to solve. So Y, or the coins returned, is actually about 16. Because you can't have part coins. Okay? The last one here, you'll say it says that it's quadratic, so we'll get a little bit of work on this. So the chart below shows the weight of fish in thousands of pounds. It's just decimal, so they don't have to write it all out. Caught in area lakes for 6 consecutive years. So, once again, we don't need exponential now. We want to come down here to our polynomial regression calculator. And yeah, it doesn't say quadratic specifically because your degree tells us that this is a quadratic, not a cubic or a quintic, etc. So you can go ahead and plug in your information. So x is talking about time. This time they call it t, so we'll have a different variable than x. Still works the same though. And weight I'll still call y. It is a degree of 2. We want 4 decimals, so let's calculate it. And it gives us our equation. Now, it doesn't ask us for our quadratic equation line of best fit, but I'm going to go ahead and write it down because we're going to need it. So I have y is equal to, notice it has to look like a quadratic equation, so it's kind of long, negative 0.3696, and then t squared, plus 1.6168t, plus 13.5964. So I've got my equation here. The actual question is, based on the best fit quadratic model, at which value of t will the amount of fish caught be approximately 6,700 pounds? Well, since everything is in the terms of this decimal, it would actually be about 6.7 that we're looking at right now. So if I plug this in, I can go ahead and solve for one side to equal 0, and then I can use the quadratic formula to finish out the problem. Thing is, most of us probably don't like the quadratic, so if you don't, you could also just go ahead and use the polysmelt function on a graphing calculator. Desmos calculator does not do that. So if you need review on how to use polysmelt, let me know. I'm just going to go ahead and say that when I use polysmelt, I got 2 answers. One of them was 7.0, so actually it was a t equals 7.029, and t equaled negative 2.654, actually. Anyway, you can't have negative years, so obviously you can just get rid of this answer. So about 7 years is what you will need. Now, if you don't know how to use polysmelt and you don't remember how to solve the quadratic formula, it's not the end of the world. Use your brain. You know one of these has to be the right answer. So For example, I already know 7 is the correct answer, so I'm going to show you with that one. I am going to plug 7 into my equation I'm given and see if it gets me close to 6.7. So I'm going to plug this in. I know I'd have to take 7 squared, so that's 49. Okay, so when I multiply these, that is my answer for the first part. When I multiply these, that is my answer for the second part, and then I'm just going to take these and either add or subtract everything. So in the end, I get about 6,800 pounds, but out of all of these, if I had tried them all, this would be the closest to 6.7. So 7 years is my best answer. So either way you do it, either just solving using polysmelt for that quadratic or finding using your multiple choice answers is a good way to go. Okay? That's all I have for you today. You'll notice on this Google sheet that for your homework problems, I actually have already typed out all of the data sets as well, so you can see which one kind of regression you're using and what the data set is, and then you just answer the questions how they want, either for some sort of prediction or just the equation. Okay? That's all I have. Have a great evening.